Hi, today we're looking at the voltage multistage 10 in the context of a large patch. And the way I wanted to approach talking about it today is through an idea that probably a lot of you are familiar with, maybe some of you are not. And that is kind of getting to the heart of one of the reasons why this is 10 steps long, which is the type of variety which arises when you have a sequence of an odd length that contrasts with something that's divisible by 4, 8, 16, 32, which is the way that a lot of our music is organized, and that the 10 sort of gives you this default way of approaching that sort of music with a type of variation that arises from contrasting a number like 10 with a number like 8, 16, and so on. And we're going to start from 0 here, so it's obviously going to take a while, but I hope it's clear what's been explained, and if it's not, you can comment and we will try and explain it better. So yeah, basically what we're going to do is have 2 voices controlled by each of these sequences, and the top row of each sequence is going to control the decay time of both voices, and the bottom row is going to control the filter cutoff. But again, kind of the point of what we're going to be getting at here is how contrasting sequencer length creates a type of variety which can then be elaborated on with other forms of control voltage to build a patch that is perhaps timbrally static but has a lot of variety in what's actually happening on a more micro level. So let's get patching. So yeah, harmonic oscillator will be one of the voices going into an amp and tone. Same with the complex oscillator into its own amp and tone. And much later down the line, we're going to be using the Bach filter. So it's running the harmonic oscillator through there, but it's going to be doing nothing special right now. And into the multi-delay, and it'll be taking the complex oscillator directly into the multi-delay. So now we need some gates to trigger envelopes to control the volume of the voices. So I'm going to use gate output from the 10 to trigger an envelope over here, gate output from the 16 to trigger the second envelope, and then connect these to the amp and tones, and they'll be controlling the volume. Using the exponential inputs here because we're going to be doing something pretty percussive in nature. And what else I need to do is make the sequences synced. So I'll use the ref output of the 10 into the advanced input of the 16. And when we play, now they're moving in time together. So yeah, we're even at the point where there's some audio happening already. And that's going to be our final output. And this is probably going to sound incredibly boring right now, but this is the starting point. But don't be afraid, it will get better, hopefully. So what we need to do next is set up our modulation, which is going to be coming from the rows of the 2 sequences. So I want to modulate the decay time of both the voices. That happens here, and you notice that there's no attenuator. So I need to use the control voltage processor to attenuate the signals coming from the sequences so that they're in a useful range for these envelopes. So sequencer 1 in here, going to the first envelope. Will this be long enough? Yes. Second sequencer into the second row here, into the second envelope. So now when we get to moving these, we're going to be controlling the decay time. So let's just do that first. So now we are ready to program our decay time modulation. And to just make that a bit more obvious, what I'm going to do is make both the sequences a shorter length. And then we'll get to talking about what we're here for, which is the interesting variation that arises with sequences of different lengths. And so let's just start with one of these. Here's our profoundly interesting sound. So this is no decay, and when I raise one of these sliders, the decay time gets longer. Right? And that's going to be the same with this second voice. Again, very interesting right now. Right. And so this is going to sound boring for a second, but the point is that we're going to listen to these being the same length and how it repeats the same way over and over again. So boring by design. All right, so within this, we can change where the decay gets longer. So we have opportunity of creating variety in this way. But you hear how the relationship is the same with every single repetition. So what happens when I make one of these one step longer is the relationship is going to become offset in such a way that it repeats. It takes a long time for them to actually get back to where they're repeating at the beginning again, if that makes sense. So hopefully now you can hear how the decay time here is opening at a rate slower to this one, and we get this phasing relationship between the two. But then now if I make this sequencer a step longer again, even though they're both odd, they still repeat around the same way over and over again. So the point is having one that's different to the other. So at this point, let's just make one of these a step longer. And we can get to programming our filter cutoff, which I haven't patched yet actually. So let's just take this down for a second so that we're not listening into that droning on. So the B row down here is modulating the cutoff of the complex oscillator voice, and the B row of the 10 is modulating the cutoff of the harmonic oscillator voice. Let's just start with the harmonic oscillator. So an important thing to consider here is that if you're opening the cutoff on a step which has a really short decay, it's not going to be very obvious what the difference is. Okay, so then let's do that with the complex oscillator. Turn up the harmonic oscillator again. Okay, so now I feel like we've gotten the point across with this, and I'm going to take these out and we can program something to the full length of these sequences. Again, hopefully you can hear that relationship of them moving in and out of phase. But now what we're going to do, as I said, this is kind of like a good starting point for ensuring that a patch has a kind of bedrock of inherent variety, which we can then develop with different types of modulation, which we're going to get into now. So I want to use quantized randoms to modulate the bark filter. And what that means is that each time the random sampling quantized random section gets a new pulse, we get a different value. So even though the output is random, it's in time. So we're going to be pairing that type of quantized but random modulation with this pre-existing modulation, which is repeating the same way over and over again, but they're in a phased relationship. So let's just focus on the harmonic oscillator and the bark filter. So I'll take this quantized random output to control the width. And we can hear this is not repeating in any way. And I'll take the second quantized random output to modulate the center. So that's giving us some higher frequency moments. Let's hear how that sounds. Okay, so we're starting to get somewhere now. Purely out of personal taste, I want to add some audio rate modulation. To the complex oscillator, I'm going to do amplitude modulation with a square, which creates a sort of like almost like a bit crushed high frequency aliasing kind of sound. You can hear it better now that I'm opening the filter more. But I also want to audio rate modulate the harmonic oscillator, and I'm going to use the square from the same modulating oscillator for the FM input. So I'm surprised how in tune this sounds, honestly. I want it to be a bit more discordant. Yeah, I'm okay with that. And I should just generally say there's no melodic information being used here at all. And so obviously it gives it quite a droning, monotonous vibe depending on your taste in music. But at home a lot I would be using a MIDI to CV converter with an external sequencer connected to the volt per octave inputs, which then can turn this sort of thing into pretty melodic music with harmonic relationships and so on. So just bear that in mind. Okay, so this is a bit more timbrally interesting now. So we've got our quantized randoms, and now I want to put some completely unquantized variation in the patch. So what we're doing is stacking up different types of control voltage information in the hope that we get this kind of rich variety when they're all combined together, based on the foundation of the sequences being different lengths. So polyphonic envelope is looping around, it's cascading on itself, and I'm going to use one of the envelopes to turn up the pitch of both the oscillators, so we'll get a whoop type sound, like that. But of course this isn't in time with anything. And I might as well use one on the modulating oscillator. I'm going to send it down because we don't have much space to go up here. So yeah, getting that unquantized control voltage in there takes things to another level in terms of the type of complexity that's being laid up on top of itself. And just finally, because we're here and we have a sequence selector, I'm going to advance it at a slower rate, and I want to use the CV out, which is generated from the sliders here, to open the VCAs of both the amp and tones. So we'll get a step where the volume just stays high. Like that. And for the other voice, I'll use a gate output to do the same thing. So we can always go back to our sequences and kind of change the bedrock of what's going on here, of our decay times and our filter cutoffs. But otherwise, that's more or less all I had planned to talk about, and hopefully that was of some interest. And yeah, if you've got anything to say, any questions, just comment and we'll get back to you. And thanks for watching.